Okay, how do we deal with uncertainties and gradients in LoggerPro? Well, first we need to put our uncertainties into our graph as error bars. I have my uncertainties already calculated from Excel. Since I'm graphing 4 pi squared r cubed against period squared, I need the uncertainty in 4 pi squared r cubed. So I'm going to have to insert a column. So I go to Data, New Manual Column, and I'll name it, I'm just going to name it percent uncertainty in 4, let's do 4 pi squared, 4 pi squared r superscript cubed. And short name percent uncertainty r cubed, because the percent uncertainty in r cubed is the same as the percent uncertainty in that. The units, well, it doesn't have units, it's a percent uncertainty. So done, I have a new manual column, percent uncertainty r cubed. So I'm just going to copy and paste my percent uncertainty values into Logger. They're all 3%, but in a lab that you do, they might all be different. Let's also add our column for the uncertainty in t squared. So again, data, new manual column. Let's do it percent uncertainty t squared. Short name is just going to be percent t squared. Doesn't have units. Done. Yes to interpret as percent. Let's copy and paste our values in. Control C from Excel. Control V. Now I have all of my values. Now I have all of my values in Logger, so I just need to add error bars. Since I'm graphing 4 pi squared r cubed, all I need to do is go to that column in my data table and double click it. That opens up the manual column options, and I can, if I go to options up here, I can add or remove error bar calculations. So check the box for error bar calculations. We're going to do percentage error because all my errors are in percent. And I'm going to use a column percent uncertainty in 4 pi squared r cubed. Press done. Yes, I'm interpreting them as percent, and we can see the error bars have shown up. They're not huge, but they do exist. Some of them are quite small, but that's okay. Not a lot of error there. Do the same thing for period squared. Double click, go to options. Error bar calculations are already on. I'm selecting percentage. My data set is going to be the percent uncertainty in t squared. Done and done. I am, yes, going to interpret them as percents. Again, pretty small, but they are not non-existent. Okay, so last thing we need to do, if we want an uncertainty in gradient, we need to get a maximum and minimum slope. So to do that, I need to add a movable line so that I can get a maximum and min slope. So what I'm going to do is I'm going to select everything. And to do a movable line, I'm not going to do a linear fit. I need to add a model. So go to Analyze at the top, Model. And I do want it to be a linear model, mx plus b. Select that. And hit OK. It adds a manual fit for my data. It's the same as my linear fit. But I'll double click my model or my manual fit. There's a checkbox down here, Enable Line Drag. Click that, check that, press OK. Now you can move the line up and down. So we can see that we get a little move up and down indicator on our cursor. So I'm going to get my max best fit line, so I'm going to make sure that it's within my error bars up at the top. And I'm going to try to make sure that it's within my error bars down at the bottom too. And then the gradient of that line is going to be my maximum slope, 1.400 times 10 to the 20. Now I need my minimum line, so I'll add another model. Analyze, Model, mx plus b. Okay, this is my new model. I'm going to double click it, enable line drag, okay. And we want a minimum slope, so I'm going to lower the model so it's within my error bars. And I need to raise it up just a little bit at the bottom to get that minimum slope. The bottom error bars are quite small. And then we have our maximum and our minimum slope and our best fit line. So we can use the maximum and the minimum slope to get an uncertainty in our slope or an uncertainty in our gradient. And the range of that slope over 2 will be our uncertainty in our gradient. In this case, our gradient is big G times the mass of the star that we're orbiting.